She does her job. We see to that. But she's not a luxury hotel. It takes a crew of 7 and needs an overhaul every 3 years. Must cost them a quid or two, I dare say. Now they've found a better way. A new type of lighthouse replaces the old lightship on the Royal Sovereign Show. At the beginning, extensive tests of models and consultations with oceanographers before the final design was agreed. This new style lighthouse was constructed in 2 main sections. First, a cellular concrete base 104 feet square by 20 feet high. Built with the base was the tower section, which was in fact 2 towers, one telescoped inside the other. Fully extended, the tower reaches a height of 70 feet above low water spring tide. On top of the tower and built separately, the cabin, with power equipment for the light, foghorn, and radio beacon and telephones. Not forgetting accommodation for the crew of 3 keepers and up to 4 visiting technicians. The roof, a flight deck for helicopters. The whole structure designed to last at least 50 years. The construction site was on the beach at New Haven, near where the ferry leaves for Dieppe. Construction of the base began with the placing of precast concrete segments to act as cutting edges and a skirt. Engineers will be interested in the concrete. It was reinforced with both mild and high tensile steel bars, with the main walls of the base and the tower pre-stressed with McAlloy bars. The concrete mix was designed to have a works cube strength of 8,000 pounds per square inch at 28 days, where pre-stressed, and 6,000 psi everywhere else, with special attention to high density and a good durable surface. The water-cement ratio was kept down to 0.37 with the aid of a plasticizer additive. "50 yards from the base construction, the ground was prepared for the building of the cabin. An area was leveled, steel girders set down, held parallel by steel tubes, and a thin layer of concrete used to finish off this working base. On the steel girders, roller skates were accurately lined up. With these, the cabin would later be rolled onto a temporary pier, constructed in the berth. At the other works, the lamp and its power units were being assembled and tested. The slowest motor in the world drives a turntable which has no gears and only one moving part. The lenses rotate to give a flash every 20 seconds, and the 1,000-watt lamp shows a beam which can be seen for 45 miles in clear weather. At New Haven, construction was going well. The central core of the cabin would eventually have to match up very accurately with the tower. This was achieved by a system of steel tubes with templates, which would match exactly with a compatible system in the top of the tower. Both steel and timber shutters were used for the tower. The two main oil fuel tanks acted as internal formers. Then, the final stages. The cabin roof has been completed. And now post-tensioning the main walls of the base. Here, the inner tower is almost complete. So too is the shell of the cabin, with the 25-ton tower made in the Gray's yard of Christiani Nielsen placed in position. Finally, the task of moving the base to its seabed home. Despite the problem of the sea washing back the gravel almost as fast as it was dug away, a breach had to be made deep enough to let the base be floated out on a normal high spring tide. The base was fitted with blocks of polystyrene to reduce the draft. It was going to the Royal Sovereign Shoal area, where there has been a light vessel since 1875. The most suitable site for the new structure was here, 8 miles off Eastbourne. Although the seabed was generally flat enough, it was covered with boulders, and these had to be individually charted and removed. Then a bed of gravel was laid to form a foundation. It was dropped from barges and screeded level by divers, a long and costly job. The base was taken out of the berth in June 1969 and parked in the bay to make way for the work of preparing the cabin to go to sea. It completed its 16-mile journey a year later, when the seabed was ready, setting off one evening at 6 o'clock in thick fog. Traveling through the night, it arrived near the site at about 3 in the morning, which should have been first light. But persistent fog prevented an attempt to moor up until the midday slack water. Then, at low tide next day, the flooding valves were opened and the sinking operation began. The base was flooded to make one side go down first, under control of 4-ton Admiralty buoys. These came into action progressively, preventing any tendency for the tilt to accelerate. The first side touched the sea bed, and further cells were flooded to bring the base firmly down. Then the boys were released. Special sandbags at each corner under the base took the weight when it first settled on the bottom. Water was jetted through the base to wash sand out of appropriate bags, so that the high parts sank and the cutting edges bit into the gravel. Next, pea gravel was pumped from a barge, down injection pipes through the base to fill gaps and ensure a good foundation. Difficult though the first stage had been, the next one would be even trickier. Back on the beach, the cabin was jacked forward onto a temporary pier in the basin. It would then be possible to let the pontoons in. But before these could be floated into position under the cabin, it had to be jacked up 6 feet. The cabin was now complete, with light and fog signal. It rested on its pontoons, waiting for its first voyage to sea. The plan was to tow the structure to Portsmouth Harbour, from where it could be taken to join the tower with only 36 hours' notice at any state of tide. 6 weeks later, the OK. The tow turned out to be very stable, and they managed a speed of 5 knots. To fit in with the tides, most of the journey was through the night. The tower was made ready, and a Trinity House boy lifted out of the water to make way for the cabin. The cabin, like the base, was moored and winched into position. To mate with the tower successfully, it had to align to within plus or minus 1/4 of an inch. This was achieved in stages. Locating arms on the pontoons mated with the cheek plates on the tower and reduced the error to plus or minus 5 inches. Finally, 2 16-inch locating pins were lowered from the center of the cabin into mating holes in a framework in the tower. As the tide fell, the pins were forced home, bringing the cabin and tower into accurate alignment. Temporarily, the cabin rested on the outer tower, with rubber buffers to absorb shocks. As the tide fell further, the pontoons were towed away. The support frame was cut and lowered into the water. Then the suspension rods were cut and the support frame towed away. Before the inner tower could be raised, 96 high-tensile steel bars were coupled through the core of the cabin to similar rods in the inner tower, later to be pre-stressed and form a monolith of cabin and tower. At the bottom of the tower, between the underside and a steel ring beam, were 12 150-ton double-acting hydraulic jacks. High-tensile screwed rods anchored at the top of the outer tower supported the ring beam through individual compensating jacks. Extension of the jacks raised the tower 9 inches at a stroke. Nuts on the bars were run up to hold the tower while the jacks were retracted, bringing the beam up with them, ready for the next stroke. Preloaded concrete wedges with special sliding surfaces between the towers ensured that the inner tower couldn't fall on the workmen below. "10 days of work. The tower fully extended, and the next task, to concrete an extension collar round the inner tower to make the final structural joint. The concrete could have been made in a ship and pumped aboard, but a helicopter was more economical because it was less dependent on the unpredictable local weather. A retarder was added to the concrete mix to allow for the time between mixing at Eastbourne, flying out, tipping onto the deck, and shoveling down a 40-foot-long tremie pipe to the men on the collar. To complete the operation, the perimeter of the base was pitched with rock to prevent scour, and sand was pumped into the base to provide full design weight and security against 50-foot breaking waves. The job was done. A permanent, different lighthouse in the English Channel. The new light, the electronic aids, and the fog signal that will blast its warning for 5 miles. Inside, all was ready for the new crew to take over.
We were going to sea from the Waterloo Dock, and the boys and the girls on the pier and they flung to give us 3 cheers with a hearty way. Oh, she's a Liverpool packet, oh Lord, let her go. Now we're ploughing our way down the wild Irish Sea. Our passengers happy as happy can be, and all the sailors saying they walk to and fro. She's a Liverpool packet, oh Lord, let her go.
For the opening ceremony, the VIPs, of course, arrived the modern way. Alternatively, you can come on board from a boat or climb up a ladder.
Great pleasure to welcome you all here to the commissioning of this Royal Sovereign Lighthouse, which I now declare operational.
But I would like to give you a warning. When our Deputy Master brings into operation the navigational aid, the fog signal is extremely loud, and I would suggest please take care, because it is extremely loud if you've never heard a fog signal before. Thank you.
For the lightship, the end of a 100-year vigil over the Sovereign Shoals. For the mariners, life goes on as before. The new lighthouse and the safety it provides will soon be taken for granted. Just one of the many lights in the Trinity House chain round the coast.